And while the Matric Class of 2023 have achieved a pass rate of 82.9%, the highest pass rate in the history of the National Senior Certificate examinations, there's a concern with the number of learners electing to do the easy maths literacy rather than the regular mathematics for Matric. Maths literacy learners jumped by 108,642 between 2020 and 2022, and that is compared to pure maths, which increased by only 36,419. This may have significant implications in the future with the AI economy set to take up space. Some learners are likely to experience limitations in the world of AI. But to take this discussion further, we're going to be joined via video link by Ari Katz, Boston Online Home Education. Ari, good afternoon. Thanks for your time with us on the SABC at this hour.
Good afternoon, Liesl, and thanks for having me on your show.
Perhaps for context's sake, we could look at what is transpiring today by trying to understand the problem that started with South Africa's history, at the start of our democracy. And in the same breath, as we look at the strides that have been taken, from your vantage point, what are the gaps that you're still witnessing?
So I think we need to look at the pass rate in context. So first up, congratulations to the matriculants with their 82% pass rate. However, we have to look at that, as I said, in context. Firstly, let's look at the number of learners who probably started schooling around 2012, which is approximately 1.2 million of them. So if we look at that as the starting point, and we think of the fact that only 572,000 of them passed, then the pass rate isn't really 82% of those who started in 2012, but it's probably below, it is below 50%. So that's quite significant in our lives. But I think what's also significant in terms of what you were mentioning in terms of AI and the future of the knowledge economy is that only 262,000 matriculants actually wrote mathematics compared to mathematics literacy. Now, if you're looking to enter the world of AI, if you're looking to enter the world of science, engineering, technology, medicine, then of course you need mathematics as the starting point. And if we look at the 262,000 learners who wrote mathematics, only 65% of them passed. However, only 16% achieved over 60% in mathematics. And that, of course, has dire consequences for the future human capital of South Africa in the digital economy and in the world of AI that we're about to, that we've already entered.
No, absolutely, Ari. Actually, perhaps you could speak to the knock-on impact that this is going to have on the shortage of our future professionals and the future labor force of South Africa, just South Africa competing globally as well.
So as I mentioned, we've obviously entered the knowledge economy, and AI and technology is the future of the world. No more are our learners competing with their neighbors next door, but we're now part of the global economy. And to be part of that global economy, we need to be producing professionals in the areas of science, technology, engineering, mathematics, medicine, etc. Now, if only 16% of our learners are able to achieve more than 60% in mathematics, clearly the knock-on effect is going to be that those learners who do enter university in those areas of STEM are going to have deficiencies in their fundamental knowledge of mathematics. And that's going to have a knock-on effect in, number one, the throughput rate at university. And even if we do manage to get throughput rate, the rate of passing is going to be significantly slower, which is obviously going to have a much higher impact on cost of university education in South Africa. But if we want to really compete in the knowledge economy, we're going to have to do something drastic to actually convert learners from maths literacy to pure mathematics.
Well, Ari, some are questioning whether South Africa's current educational space prepares our learners adequately to meet the skills demands of the future. And also, when we look at the role of early learning, how does that assist along the journey? You know, looking at how to build on knowledge that is acquired from an earlier age. What are your observations on that front?
So I think there are a couple of things. First up, we need to take a look at the PRIL study that was done. And you will notice that when in the PRIL study, we performed very poorly in mathematics, which was evaluated at grade 4 and then again at grade 9, with less than half of the learners being competent at those ages. So that's number one. And then we have to ask ourselves why. And I think there are two fundamental reasons that we need to look at. Number one, there's a very interesting study that was done amongst Bachelor of Education students across 3 universities, where only 50% of them were able to pass primary school mathematics. Now, if our teachers, only 50% of them are able to pass primary school mathematics, how are we going to teach kids at school pure mathematics? So that's number one. I think we need to look at the teacher training and up the standards in terms of that level. That's number one. Number two, I also think we need to look at how we teach mathematics. So up until now, in terms of the PRILS report, approximately 1/3 of the curriculum is rote learning, process-based. Whereas if you look at some of the international curriculum, such as Cambridge, for example, 2/3 of that curriculum is interpretation, analysis, application, etc. Now, if we want students to really understand mathematics beyond simply being able to do calculations, then we need to be able to increase the level of application, analysis, interpretation, etc. So when we teach mathematics, it should not just be process-based, but it should also be understanding concepts. We should focus on the why as opposed to just simply the what.
Well,
I understand what I'm saying around
yes. No, absolutely, because I wanted to then look at ways in which we can tackle the obstacles to learner participation in an AI-centric world. How do we accelerate AI literacy in South Africa, given the inequalities that exist, the obstacles, the barriers to entry as well?
So seeing as though you're talking about the world of AI and the digital economy, we should talk about how we harness technology and AI for the benefit of teaching and learning. So if we harness if we harness online learning, we're able to utilize data to understand student problems. So for example, in an online environment, I'm able to understand exactly what a learner understands and what the learner doesn't understand. So for example, I can assess and report that these learners can add and subtract, and these learners cannot multiply and divide. So I'm able to pinpoint the problem, and then I can remediate that problem. In addition, I can use technology such as adaptive learning, where I start with simpler problems, and as the learner progresses at his or her own pace, I'm able to increase the level of difficulty of the questions and what I'm teaching. And in that way, we can harness online learning to the benefit of increasing depth of knowledge of mathematics. And in addition, we can pinpoint problems in fundamentals and address fundamentals, so we don't just progress learners through the system from grade 2 to grade 3 to grade 4, etc., but we're able to identify what their gaps are and redress those specific gaps. So the one thing that I would really like as a takeaway is for us to think carefully about how we utilize online learning to enhance teaching and learning, particularly of STEM subjects.